working with graphs. So think back in chapter 4, and we graph trig equations. We know that like if you had sine of x, and you don't necessarily have to write this down, this is just kind of our conversation here. We know sine of x, so we would start sine has a high point of 1, low point -1, and it looks like this. Okay, but when I said sine of 2x, remember that changed the period of the graph? Normal period was 2 pi divided by 2, had a period of pi. And so what happened is that graph got skinnier. So by the time you got to pi, it had already graphed a full cycle. So if I'm asking you to find when, for instance, this is equal to 1/2. Okay, the black one, if I said when sine of x equals 1/2, we get 2 answers. It happened here, and it happened here. But that red graph, if I said between 0 and 2 pi, tell me every time it equals 1/2, we get 4 answers, because that 2 made the graph repeat faster, and so we get more answers. So what we're looking at in this section is what happens when your angle changes. We know that changes the period, so it will change how many answers we get. So let's look at this problem. I wanted to solve this equation. We start out solving it just like normal. So my angle is x over 2. I'm not going to let that change anything yet. If I want to solve this for cosine, we get the cosine by itself. We divide by 2. And we're just finding when cosine is equal to radical 2 over 2. What quadrants is cosine positive in? Reference angle. When is cosine radical 2 over 2? We are in radians. So, my angle is x over 2. In quadrant 1, pi over 4 is pi over 4. In quadrant 4, that is 7 pi over 4. But I need to know what x is. So what we're going to do, if you want to get x by itself, you just have to multiply by 2. So you have to take each of these answers times 2. So we get x to equal pi over 2 and 7 pi over 2. Are there any questions there? So, my questions. When I say part A, find every answer between 0 and 2 pi. 7 pi over 2, that's like 3.5 pi. That is not in my interval. Pi over 2 is the only one that fit in my interval. The reason, if you think about this graph, normal period for cosine is 2 pi, divided by the 1/2 is 4 pi. So it took my cosine graph and it stretched it out. We don't get to the end until we get to 4 pi. At 2 pi, we've only done half the graph. So that's why there's only one answer between 0 and 2 pi. If I said all possible solutions, that's when we take each solution and we add the period. So I do need both of those But my difference, now I'm not adding 2 pi k. This graph has a period of 4 pi, so it will be a distance of 4 pi before it repeats. So I'm going to add 4 pi k to those, where k is an integer value. So because the period is different than just 0 to 2 pi, we have a few more things to take into consideration. What questions do you guys have right there? Let's look at another one. Alright, so this one, I already have sine by itself. We need to know when is sine equal to negative 1. Okay, so my angle is 3x. When is sine negative 1? Unit circle, sine is the y, so if y is negative 1, that is at 270. And I did say radians on this, so 3 pi over 2. Okay. Now here's the deal. If you think about this 3x, your normal period is 2 pi. Divide by 3, it's 2 pi over 3. So between 0 and 2 pi, what happens is we actually get 3 cycles of our graph. There are 2 different ways we can get the answers on these. I'm going to show you what I think is the easier option, and if you don't like it, I'll give you another way. Okay? When you see this 3, what it means is we are going to have triple solutions. Because by the time you get to 2 pi, your sine graph will have repeated 3 times. So instead of just getting my 1 answer, there's really 2 more. One way to get it is just to take this answer and add 2 pi to it. Okay, so you notice I still have 3x equals, so I have triple solutions, so I need to get 2 more. So if I do 3 pi over 2 plus 2 pi, you can do it on the calculator, 3 over 2 plus 2, we get 7 pi over 2. And we add 2 pi again, 7 pi over 2 plus 2 pi, it's 11 pi over 2. And so now if I want to find x, what would I have to do to all of those answers? Divide them all by 3. So if I divide by 3, we get pi over 2. Oops. Have a good break. Thank you. 7 pi over 6 and 11 pi over 6. So this one was a little bit different. On the first one, when I said 0 to 2 pi, I had to throw out one of my answers because this was a 1/2 x, we only had half of the graph by the time we got to 2 pi. This one, because it's a 3x, I have 3 complete cycles by the time I get to 2 pi, so that's why we have triple the answers. There are other ways I can figure this out, but I don't want to confuse you. So do you understand this way? We'll just do them like that. All of these are between 0 and 2 pi. So that's our answer for part A. Part B, when it says all solutions, then we have to think back. Our original solution was just the pi over 2. Right, we only had one solution to start with. Plus, if we add our period, the period is 2 pi over 3. So plus 2 pi over 3k, where k is an integer. There are other ways you can get that as well. It's more to write, but you could have done all 3 of the answers from part A plus 2 pi k. That would be equivalent, not the most concise, but it is going to give us all the same answers. So there are some different ways that you might choose to write that answer. Most of the time on these, I am just going to have you give me the answers between 0 and 2 pi or 0 and 360 for the most part. A couple times I may ask you to do all solutions, but not very often. But you just have to take your original solutions and add your period to them. All right. Let's do another. Okay, this is a problem because we have 2 different trig functions. So we need to get them in terms of 1. So this is when I would go to my flip chart. What do you think would be your easiest option? Can we change cosine 2x to? If I do that, let's bring everything over to the right because I like my square term positive. So I add over my 2 sine squared x. Subtract my 1. This time my angle is just x. So are we going to have to worry about double or triple solutions or anything weird like that? No. So sometimes you might be able to use an identity to get rid of it. And then this is like our other problems that we've been doing. So if we slip and slide, what multiplies to -2 and adds to +1? Have to divide our 2 back. Equals 0, so you get sin x equals -1 or +1/2. Okay, so now we just have to solve these. No extra solutions because my angle is just x. When is sine equal to -1? And we are in radians, just between 0 and 2 pi. Sine's -1, that is at, sine is 1/2, it's positive in 1 and 2. Reference angle is pi over 6. So pi over 6 in quadrant 1 is pi over 6. And in quadrant 2 it would be 5 pi over 6. Yeah. Is that one okay? Let's look at this. Is this one that I'm just going to be able to do an identity and get rid of? Probably not. So we're just going to have to deal with it. What I see when I look at this, as soon as I see the 2 theta, I'm going to make myself a note that there are double solutions here. So if I wanted to solve for my secant, divide over the negative. If you don't like thinking about secant, you could do cosine as a reciprocal. So that's negative radical 2 over 2. So then quadrants, cosine's negative and 2 and 3. Reference angle, when is cosine radical 2 over 2? We're in degrees this time. So my angle is 2 theta, so this is 2 theta equals 45 degrees in quadrant 2 is 135. In quadrant 3, 180 plus 45 is 225. But I said we have to have double solutions. So I currently have 2, that means I'm going to get 6 total. The easiest way, I think, is before we go ahead and solve for theta, just add 360 to all of these. Okay, so if you add 360, oops, I tripled my answers, didn't I? I said double and I wrote triple. And then add 360 to this one. So now to get our final answers, we just divide every one of those by 2. So 135 divided by 2 is 67.5. 225 divided by 2, 112.5. 495 divided by 2, 585 divided by 2. so if I look at this 2 sine squared 2x minus sine 2x, and subtract my 1 over. Because it's a 2x, I know I'm going to get double solutions. Right? Then we would just slip and slide. This is very similar to the problem we did a minute ago, except when I factor it, it's sine of 2x. So multiply to negative 2 and add to negative 1 would be negative 2 and positive 1. So if we set those zero up, undo your slip and slide, so divide by 2. We get sine 2x is equal to 1, negative 1 half. So my angle is 2x. We are in degrees. So when sine is equal to 1, that happens at 90 degrees. Sine is negative and 3 and 4. Reference angle, sine is 1 half at 30 degrees. So 30 degrees in quadrant 3 is 210. In quadrant 4, 360 minus 30 is 330. But we said double solutions, so we currently have 3, so we have to have 6 total. So add 360 to each of those. And then we divide every one of them by 2. Is that one okay? So that's part A. This one, I'm not going to do that on a lot of them, but it said all solutions. If it's all solutions, all you'd have to do is take the 3 original. So our original 3 were these. We have to add our period to each of them. So if you think about the period, normal period is 2 pi or 360 divided by the number in front of x, which is 2, so it's 180 degrees. So you could say each of those plus 180k. Where k isn't it? The alternative, an equivalent way would just be to say each of those 6 answers plus 360K. It's more to write, but if you don't want to have to figure out your period, you can take all those other answers. Just add your 360. Is this okay? I'm going to stop here for today.